Okay, so today we're going to overview the shear test and determining Poisson's ratio and the shear modulus, or the modulus of rigidity. What you'll be doing is playing with using, I should say, the Mark 10 load frame that you've used already for the tensile test with the tensile grips in it. Then you'll be provided some samples that are textile material. So instead of a homogeneous material such as the polymers that you tested in tension before, we'll look at the actual structure and how that behaves in both tension. And the second setup is to shear load the sample. So the same thing that you've used before, the dial indicator, the load cell that gives us the applied load, and then we'll be bringing up some video software that you'll be using to capture the image of the material as it elongates with the digital camera over here. So we're using digital image correlation software as part of your post-process or post-lab analysis. All right, so now we are going to do the tensile test. We already have the fabric loaded in the grips, or the frame support, if you will, that will go in the grips. I'm going to go ahead and just simply measure the thickness of it, and I'm approximately 0.017 inches or 17 thousandths. I don't know that I need it, but it's always good practice to measure the width and the length. In this particular case, the length is approximately 4.832, and the width, though I may not need it again, is approximately 4.30. I can take the textile material and load this in the tensile grips. And you want to take your time and make sure you're sensitive and all. All right, great. And then I'm going to use the Allen wrench to tighten that up. Each time I have zeroed the dial indicator to start already, and I can zero the load, though I do have a little pretension on it. I can do that and zero that out. And what I'm going to do is I'm going to start loading this up using the hand wheel, and I'll record the elongation or travel in the y direction as a function of load being applied. So I'm going to actually get the preloaded length, 4.925. Okay, so the next thing we're going to do is load the GOM Snap software, which is located on your desktop. So once the software comes up and initializes, we're going to go and do a new project. And then we're going to initialize the camera, which is this icon up here. At which time we can see on the screen that we have we have an image of the textile material that's loaded in the Mark 10. The other thing I need to do is set up the acquisition. And I'm going to use start measuring sequence. And here I can choose the rate at which I'm going to acquire the sample or the image. So I'm going to acquire approximately, 30 actual images at 1 image per second, or 1 hertz. Once I hit OK, it'll start recording. So I'm about to release the OK, and then we're going to load the sample up. So we're at about 5 pounds. $25 pounds, 30 pounds, 32. Okay, so now we're going to do the shear test. We have the fabric, the same fabric that we use for the tensile test, mounted 2 places with 2 L brackets on either side. So the first thing I'm going to do is measure the thickness of the material before I put it into the tensile grips. And that appears to be approximately 17 thousandths. I'll look at another place. 16 thousandths. I'll actually turn the sample and measure that one more time. About 16 thousandths. and one more. About 15,000, so you could take the average of that if you feel appropriate. Next thing I want to do is I want to take the sample and load it into the tensile grips. And you want to be careful, you want to make sure everything's centered. And you don't want to pre-stress too much the material, so I'm going to actually adjust my grips so that the material is relatively taut but not highly loaded. Okay, then I'll take my Allen wrenches and go ahead and tighten that a little bit more so I don't have any slippage. The next thing you want to do, obviously, if you need all the geometry, it's always good to measure. You know, you can never have enough data. And that's approximately, from frame to frame, 3.357. And the height of 4.202. Okay, so now we're going to go ahead. We already have the shear fixture with the textile material loaded in the tensile grips, and we're going to go ahead and load it up. I have 0 elongation and 0 load. So we're not going to see a lot of load on this. Therefore, what we're going to do is I'm going to call out every revolution being 1/10 of an inch what we have for the force. So that's 1 revolution, and I've got about 0.2 pounds. 2/10 of an inch, and we still have that 0.2 pounds. It's just jumped to 0.4 pounds. And I'm going to bring it on back probably, so that jumped to there. 0.220, it's gone to 0.4 approximately. 3/10 of an inch, I'm still at the 0.4. And 0.320. It looks like it's changing again. Approximately 0.33. Yeah, I'm going to go with 0.340. I'm at 0.6 pounds. It should be 4/10 of an inch. Still, it's 0.6 pounds. Now it's shifting to 0.8 pounds. That's a resolution increment that we're looking at. 0.2 pounds. So at approximately 0.8 pounds, I am at 0.430. And that would be 0.50, where I'm at 0.8 pounds. 0.520 is 1 pound. 0.580 is approximately 1 pound, transferring to 1.2. So that's 0.6 inches, and I'm at 1.2 pounds. So you can see the transition. Where am I at? 0.65, which is transitioning to 1.4 pounds. 1.6 at 0.77 inches, 0.77 inches, 1.6 pounds. And I'm transferring to about 1.8, I'm sorry, transitioning to 0.7 inches, I would assume. Did I mess that up? All right. 2 pounds or 2.2 pounds. I'm at 0.8, and I'm off the dial, which means I've gone an inch.